Dear students, my name is Sir Kumel, and today the topic of my lecture is series and parallel combination of capacitors. So first I will write the heading: series and parallel combination of capacitors. In this heading, I will tell you how you can find equivalent capacitance when more than one capacitors are connected in series, and how you can find equivalent capacitance when more than one capacitors are connected in parallel. First of all, we will use the formula Q is equal to CV. Here Q is the charge stored on parallel plates of capacitor. Charge stored on parallel plates of capacitor. C is the capacitance of capacitor in farad, because the SI unit of capacitance is farad, which can be represented by capital F or small f, and V is the voltage of capacitor. And you all know the unit of charge is coulombs. Now, if for example 3 capacitors I take and connect them in parallel, this is a current source which is providing current to this capacitor C1. It is providing current to this capacitor C2, and it is providing current to this capacitor C3. Current flowing into C1 is I1, current flowing into C2 is I2, current flowing into C3 is I3. So this current source is actually providing current to C1, current to the capacitor C2, and current to the capacitor C3. So I is equal to I1, I2 plus I3. Total current is equal to I1 plus I2 plus I3. Okay. Now, as we know, the formula of current in terms of charge is I is equal to Q upon T. Current is equal to charge divided by time. So what will happen now? Total current is equal to total charge divided by time, equal to Q1 upon T plus Q2 upon T plus Q3 upon T. We will take time common here, and it will be like this: Q1 plus Q2 plus Q3 bracket multiply by 1 upon T this time will be cancelled by this, and it will be Qt is equal to Q1 plus Q2 plus Q3. Total charges equal to Q1 plus Q2 plus Q3. Okay, now we know the formula. Q is equal to CV. Q is equal to CV. Charge on parallel plates of a capacitor is equal to capacitance of a capacitor multiplied by its voltage. So here Qt is equal to CVT. What does it mean? Total charge stored on parallel plates of a capacitor is equal to capacitance multiplied by total voltage of a capacitor. Qt is total charge and Vt is total voltage. So it will be like this: CVT is equal to C1 Vt plus C2 Vt plus C3 Vt. Why? Because here the voltage across C1 is plus minus V1, the voltage across C2 is plus minus V2, and the voltage across C3 is plus minus V3. Since there are two nodes, this is the node 1 and this is the node 2, so the voltage across these two nodes is plus minus Vt, which is called total voltage. So V1 is equal to V2 is equal to V3 is equal to Vt. That's why I have written here CVT is equal to C1 Vt plus C2 Vt plus C3 Vt. Now we will take Vt as common, so it will be C1 plus C2 plus C3 multiplied by Vt. Vt will be cancelled by Vt, and C equivalent will be C1 plus C2 plus C3. So this is the formula for equivalent capacitance when the capacitors are connected in parallel combination. This is the formula to find equivalent capacitance when the capacitors are connected in parallel combination. Now what will happen if the capacitors are connected in series? This is the voltage source, and the voltage of this voltage source is Vt. It means total voltage. This is C1, it has a voltage plus minus V1. This is C2, it has a voltage plus minus V2. This is C3, it has a voltage plus minus V3. Now you can see here, when capacitors are connected in series, current is same but voltage is divided. This total voltage is actually producing voltage across C1, voltage across C2, voltage across C3. That's why Vt is equal to V1 plus V2 plus V3. Now you know the formula. Q is equal to CV. If I will write this formula for voltage, then it will become like this: V is equal to Q upon C. Okay, so here charge is constant, charge remains same for C1, C2, C3. Why? Because current is same for C1, C2, C3. That's why charge is also same. So here Vt is equal to Qt upon C equivalent is equal to Qt upon C1 plus Qt upon C2 plus Qt upon C3. Why charge is same for C1, C2 and C3? Because current is same. Same current is flowing from C1, C2 and C3. That's why charge is also same for C1, C2 and C3. Now take QT as a common. It will be like this: 1 upon C1 plus 1 upon C2 plus 1 upon C3. QT will be cancelled by this QT, and 1 upon C equivalent is equal to, and 1 upon C equivalent is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. So this is the formula. This is the formula for equivalent capacitance. This is the formula for equivalent capacitance when the capacitors are connected in series combination. 1 upon C equivalent is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3 when the capacitors are connected in series combination. You can see capacitors are connected in series combination here. That's why the formula of equivalent capacitance is like this. So the lectures ends here. Thank you. Wait for the next video.